Hello everyone. Due to some unavoidable circumstance, I couldn't attend here. My heartiest gratitude to the WIMS authority for allowing me a video presentation of our paper, Extract and Rank Web Communities. I am Jinia Tabassum Binta Jaffar and my co-authors are Asif Salekin and Dr. Masood Hassan. In this paper, we presented a new approach of web searching through web communities. We also proposed an improved algorithm for community extraction. Finally, we proposed an approach to rank the extracted communities. First, come to the demonstration of the usefulness of our community-based web search. Suppose a user wants to buy a laptop and makes a query in the community search system. Then, we will provide him two sets of pages. Group of hub pages and group of authoritative pages. The first set of pages are blogs and articles on laptops. This will provide him information on various laptop brands. The second set of pages are of various laptop sellers. So to attract the buyers, the manufacturer companies can advertise in the hub pages of the higher ranked communities. To extract such communities, first we construct a domain graph. To construct it, we extract some web pages from the search query result of a search engine. Then we crawl the children page and parent pages from each of these extracted pages. These extracted pages, the crawl pages, and the hyperlinks between them construct the domain graph. So, the size of the domain graph is big. If there are n extracted pages, NC children pages and NP parent pages, then we will have n into 1 plus NC plus NP nodes in the domain graph. This is an example of our domain graph. First, we find the n initial pages of group A. These are the first n result of the specific search query which we get from a search engine. Then we crawl the web pages of group A and find their children and parent pages. Pages of group B are the children pages of group A. They are potential authoritative pages as they have only inbound links. Pages of group C are the parent pages of group A. They are potential hub pages because they have only outbound links. Pages of group A can be hub or authors because they have inbound links and outbound links. We have used the dense bipartite graph based notion of web community. We define a community by hub and authoritative pages of a specific search query, and these hub and authoritative web pages are related by a dense bipartite graph pattern. We represent it as DBG TIPQ. Here, T is the set of hub pages, I is the set of authoritative pages, P is the minimum number of outgoing web links from each of the hub pages, Q is the minimum number of incoming web links to each of the authoritative pages. This is an illustration of a web community. Here, each node of set T has at least 2 outgoing links and each node of set I has at least 1 incoming link. So, we represent it as DBG TI21. To get better performance from the searching system, we improved the previously proposed community extraction algorithm. We introduced the fact that in a particular domain graph, for a specific value of P and Q, every web page belongs to one distinct community. Again, instead of executing the algorithm in 2 phases, we did a simultaneous execution of gathering and pruning web pages. For this simultaneous execution, we can resolve the previous issue of finding more than one DBG patterns in a single community. Moreover, these proposed improvements reduce the memory consumption and runtime to a great extent. To get a figurative sense of our proposed algorithm, consider this domain graph. From here, we want to find a community represented by DBG TI23. So, while gathering the potential nodes of a community, when we find any parent node having less than 2 children or any children node having less than 3 parents, then we will prune it. Suppose the algorithm starts with node A. Now, while gathering its potential child pages, we will exclude F from our consideration as it has only 2 parents. So, F will be discarded from the domain graph along with its incoming edges. Now, A will be marked as seen so that we can avoid the repetitive execution of the algorithm on this node. Similarly, we can work with node B. While evaluating node C, we will exclude I from our consideration because it has only 2 parent nodes. So, I will be discarded from the domain graph along with its incoming edges. This is our final DBG pattern because we will find a converse set of parent pages and children pages. Here, we don't need to execute the algorithm for nodes GH and JK, but the previous algorithm considered all of the nodes in the gathering phase, then exclude them in the pruning phase. So, our algorithm consumes much less memory and runtime than the previous one. This figure shows the runtime comparison with the previous algorithm. We executed both algorithms for 30 similar search queries and found that on an average, our algorithm reduced the runtime by 80%. We also conducted the search with and without including our proposed fact, and we find that inclusion of the fact reduced the average runtime by 85.83%. Now come to the ranking approach of the extracted communities. We introduced R1 as the ratio of edge-weight summation in the extracted dense bipartite graph and number of edges in the corresponding complete bipartite graph. A higher value of R1 refers to the higher interlinks and strong references between hub and authoritative pages. So, according to our proposed notion of community, we can say that if the structure of the community is close to its corresponding complete bipartite graph structure, the pages of the community are highly interlinked. Therefore, that would refer to a better community. We denote R2 as the ratio between number of nodes in T and number of nodes in I. Here, T is the set of hub nodes and I is the set of authoritative nodes. A higher value of R2 refers to higher hub authoritative ratio. The final ranking R is reflected as R1 into R2. Higher value of R refers to higher communities, that means better communities. Here we use the multiplicative measure because in our experiment we use different measures and find that multiplicative measure gives the better result. That's all. Thanks to everyone for your patience hearing. If you have any query on our work, please send me an email to genia.tabassum@gmail.com, or you can also contact with our co-authors. Thank you.